Hello everyone, this is Deep, and today we will be looking at LeetCode weekly contest 323 question, maximum number of points from grid queries. So here we are given a grid of size m cross n and a query array of size k, and for each query we need to return an answer. So these are the two rules we are given for to process the query. Okay, so like if a query of I is strictly greater than the value of the current cell, then we can move in the four direction up, down, left, and right, and visit the next cell. If the next cell we are visiting is unvisited, then you can add 1 point. Yeah, and otherwise, if it is not strictly greater, then what we will end the process. So for all the queries, we need to return maximum number of points as is possible. So here first for the first grid that we are given is 1 2 3 2 5 7 and 3 5 1. Let's process the query 5. So here what we can do is see for the query 5 initial position we are at 1. Okay, from 1 we can go to 2 3 also. So let me draw this and show you. So we are given 1 2 3 2 5 7 and 3 5 1 2 5 7 3 5 1. Our initial position is this is our initial position, and our query is 5. Okay, so from where we can travel is from 1 we can travel to 2 because 2 is less than 5, 3 is less than 5. We can also travel to this 2 that is less than 5, then this 3 less than 5. Okay, afterwards from this 3 we cannot go anywhere. Since here also it is 5 5 7, so we can't visit this. So total nodes that we can visit from this query 5 is 5. Okay, so let's say if the query is 2. So from so initial position is this. So from here either we can go to right, down, left, or up. But all the neighboring cells have value greater than or equal to 2. So the only cell we can visit is this one, so we return our answer as 1. Let me take another example. Let's say 7. Okay, so what we will do, we will start from 1. From 1 we can visit to 2, from 2 to 3, 3 to 7 no, but from 2 to this 5. Then from 1 we can visit to these 2, then 2 to 3, then 3 to 5, 5 to 1. Okay, so all these cells will be visited for 7. So we would return here our answer is 1 2 3 4 5 6 1 8 8. Yeah, right. And if our query is let's say 1, then we can't visit any cell because the first cell we have here is itself 1, means that is greater than or equal to the query element, so we would return simply 0. So I hope you got the question that have to travel from the first to all its adjacent element in 4 direction, that is up, left, down, and right, and we need to return maximum nodes we can travel. Yeah, so let us move to the intuition, like let me yeah, so what we are doing here is for each query queue we are doing a traversal. So here we can do two types of traversal, either BFS or DFS. Okay, yeah, then further thing is, let's say we have processed query for, let's say, 1. So your initial is 1, then it's easier if we want to process the query for 2, because let's say for 1 we get answer as 3. So for the next element what we have to do, we just know that 3 nodes can be visited if we have 1. Then if our query is 2, then we just have to travel from these visited nodes of 1 and add to our answer. Let's say it's 2, so here we would return 5. So what the meaning here is, we would sort queries at a okay, so that will be efficient for us, because we can use the answer of the previous traversal. The next thing what we can do is we can so we want to travel this given graph. Let me draw it again. 1 2 3, 1 2 3, 2 5 7 and 3 5 1 3 5 1. So we need to travel this m cross n matrix. So starting from our starting position is this one, the top left node. So here what we can travel is in four direction. So we would maintain one queue. So we are talking here about the BFS traverser. So we will maintain a queue, but this it won't be an ordinary queue. This would be minimum heap. So what we would do is we would travel from, let's say, 1, then we would store 2, then this 2, then 3, then 3, then 5, then 5, then 1, and then 7. So these were like when we are traversing in this fashion, means taking the minimum element from the traversal. If any greater than a greater element, let's say for a we are doing for the query 3. So if we get 3 somewhere, then we would stop. So and since we have processed all the nodes that have less than value, we can directly stop there. So what I'm trying to tell here is, so we would traverse this given matrix with a minimum heap, so that if any element is encountered that has value greater than equal to query, then we would directly stop, and we would return the total visited nodes. And let's say if for our next query, let's say next query q dash, we already have p visited nodes initially, then we would add all the answer of q dash. Like here we had stopped, then for we would start again from here, let's say from 3. This much we have done for the query q. Now for q dash we will traverse till it is possible, like till here. If it is possible, then we would traverse to. So we had the answer of this initial query q. We just add this answer for q dash. So q dash answer would be points of query q plus new visited nodes. So that's how sorting the queries will help us to minimize the time of traversal. Time will be reduced as we would use the previous answer. And the next thing would be using minimum heap for traversal. So we can traverse so we can stop whenever we encounter an element greater than or equal to q. Okay, so that's the intuition behind this. So now let's move on to the coding part. So let me try to reset my ID and start the coding. So initially let's take the three sizes. So one's the size of the grid, number of rows, and number of columns, and k is the size of queries. Okay, fine. Now we will take another vector of pair int and int. Let me name it as query. So here of the size k. So here what we would do is store query value along with its index. Yeah, why we need this? Because we are sorting these queries, and further we need to return the answer with respect to its index. So we need to sort them. So we need to store we need to store the value of the query along with its index. So it helps us for our answer vector. Let me take another vector of answer k. Right now I will store all the queries into this pair of vector. Query of I equals to queries of I and its index. Right, then we can sort this query vector. Okay, now we would require a priority queue or a minimum wave. So here in this priority queue, we've got three things we have to store here is first the value of node, then its x and indices and its y indices. So we would take a tuple here. Let me copy this vector of tuple greater of tuple. And yeah, I would name these as minimum heap. Okay, now initially we are located at the first node, so I would insert min heap dot push grid of 0 0 and its indices, that is x and y axis. Then I will mark this as visited. So to mark the indices visited, we also require one boolean vector visited of size m and n, m cross n size boolean vector. Let me store it false, then visited of 0 0 is true, so we have visited the first element. Now we would traverse for all the queries. For auto n% q of query, let me name one another p, or let me name a count as 0. So this count would be the count of nodes that we have visited till now, and we would run a while loop until min heap dot size is greater than 0, means until the heap is empty. Or and yeah, we would take, let's say, value x I and j equals to min heap dot top. Okay, now this first condition, queries of I is strictly greater than the value we are visiting. So if the value that we are visiting is greater than or equal to the query value, then what we would simply break from this loop. As in the else condition, what we would do, we would traverse all the adjacent nodes, that is in top down to left right direction. And yeah, before traversing, we would simply make we would simply pop out the element first. Then yeah, traversing, like if I minus 1 is greater than equal to 0, and then the rate of I minus 1 comma j equal to false. So what we would do is we would push into our minim heap the value grid of I minus 1 j along with its x and y axis, and also we would mark I minus 1 j as visited. Okay, so this is, we have moved in the left direction. So similarly we would move in all four direction. So now here I am taking j minus 1. So yeah, just making this changes in the direction. Then the next would be I plus 1. So I plus 1 would be the rightmost direction, and that should be less than number of columns. Okay, and the last would be j plus 1, should be less than m. Okay, and for one another thing is, we would increment the count variable here whenever we are visiting any node, right? And at the end we would just simply update our answer with the indices of this query. So q dot second equal to count. Okay, great. No, and here it won't be q dot 0, it will be q dot first. Yeah, and then we would simply return our answer variable. Okay, just a small change here, it would be m, and here this would be n. Yeah. Okay, now let me try to run this. Okay, n equals to grid dot size vector. So it would be a vector of vector 2D vector Okay, yeah, it passed the sample test case. And let me try to submit this. Okay, correct. So it got submitted. So what we did here is uh, we took this minimum heap so that we can travel by taking the least value element first. Then we also sorted the query array so that we can we can first process the query with minimum value, and for another query we will simply use the previous count and increment that. And yeah, if we at the end we stored of answer in this answer vector. So I hope you like the solution. So thank you. So that's all for this video. I hope you guys liked the video, and if you have any doubts, let me know in the comment section below. Make sure you like the video and subscribe to our channel. Thank you.